What's going on, everyone? Today's deep dive is all about what is a Wi-Fi proxy. Complete guide to proxy settings on Wi-Fi. I'm going to walk you through everything step by step. So by the end of this, you'll have a really solid understanding. Let's go. If you have ever opened the network settings on your phone or laptop and noticed that proxy section sitting there, you might have wondered what it actually does. The term Wi-Fi proxy gets thrown around a lot and it covers more ground than people realize. It can mean a proxy you configure on your wireless connection, a proxy hosted by your network administrator, or a proxy you set up yourself to control how traffic leaves your device. In this guide, I will walk you through exactly what a Wi-Fi proxy is, how it differs from a VPN, how to configure one on every major platform, the use cases where it actually makes sense, and the security implications you need to think about before you ever paste a proxy address into your settings. Let's start with the basics. A Wi-Fi proxy is a proxy server that you configure at the network level on your wireless connection. When your phone or laptop is connected to a Wi-Fi network and you set a proxy, every app on that device routes its web traffic through that proxy server before reaching the actual destination. The website or service you are connecting to sees the proxy's IP address, not yours. The proxy acts as a middleman. Your device sends a request to the proxy forwards it to the destination responds to the proxy, and the proxy passes the response back to you. This is different from configuring a proxy inside a single app like a browser. When you set a proxy in your browser alone, only that browser uses it. Other apps on your device like email clients, messaging apps, or background services continue connecting directly. A Wi-Fi proxy applied at the system level covers everything that respects the operating system's network settings, which is most legitimate apps but not all of them. Some apps deliberately bypass system proxy settings, which is something I will come back to later because it matters for both privacy and troubleshooting. There are a few main types of proxies you might configure on Wi-Fi. HTTP proxies handle web traffic on port 80 and 443. HTTPS proxies handle encrypted web traffic. SOCKS proxies, usually SOCKS 5, are protocol agnostic and can handle pretty much any kind of TCP traffic. Transparent proxies are configured at the network level by the administrator and do not require any setup on your device. Hotfile proxies use an automatic configuration script that tells your device which proxy to use for which destinations. Each type has different strengths and trade-offs, but for the typical end user, HTTP and SOCKS 5 are the two you will encounter most often. Now let's talk about why you would even want to use a Wi-Fi proxy. The first big use case is bypassing network restrictions. Schools, offices, hotels, and public Wi-Fi networks often block specific sites or services. A proxy can route your traffic around those blocks. The second use case is privacy. Your proxy provider sees your traffic instead of the destination site seeing your IP, which can be useful if you want to hide your real location from a specific website. The third use case is testing. Developers and QA teams use proxies to inspect, modify, or capture traffic for debugging. The fourth use case is geo-access. Want to see how a website looks from a different country? Set a proxy in that country. The fifth use case is anti-detection for things like multi-account management, web scraping, or social media automation, where having a clean residential or mobile IP is essential. This is where mobile proxies and sticky sessions come into play, and we will get to that. Wi-Fi proxy is different on every platform, so let me walk through the major ones. On iPhone or iPad, you open Settings, tap Wi-Fi, tap the info icon next to the network you are connected to, scroll down to configure proxy, and choose Manual. You then enter the proxy server, port, and authentication if required. On Android, you long press the Wi-Fi network, tap Modify, expand the advanced options, and enter the proxy host and port. On Windows, you go to Settings, Network and Internet, Proxy, and either enable the automatic detection, point to a setup script, or enter a manual address and port. On macOS, you go to System Settings, Network, select your Wi-Fi connection, click Details, go to Proxies, and check the protocols you want to route through the proxy, then enter the address and port for each. On Linux, it depends on your desktop environment, but most use a Network Manager dialog with a proxy tab, or you can set environment variables like HTTP_proxy and HTTPS_proxy at the shell level. When you enter the proxy details, you typically need four things. The proxy host, which is either an IP address or a domain. The port, usually something like 8080.3128 or a custom port assigned by your provider. The username and password if your proxy requires authentication, and most paid proxies do. And sometimes a bypass list for local addresses so your internal network and printers do not route through the proxy unnecessarily. If your provider gives you the entire string in the format host:/port:/user:/password, you need to split it into the right fields when you enter it into the settings interface. One important thing to note is that on most mobile platforms, Wi-Fi proxy settings only apply when you are connected to that specific Wi-Fi network. If you switch to cellular data, your proxy settings do not apply. This is a deliberate design decision because cellular data carriers do not typically support user-configured proxies in the same way. If you need a proxy on cellular, you generally need to use a VPN or pair-app proxy configuration. This is one of the most common confusions I see, where someone sets up a Wi-Fi proxy, walks out of Wi-Fi range, and wonders why their proxy is no longer working. Another important detail is that Wi-Fi proxy settings affect mostly web traffic. They do not necessarily affect things like real-time voice and video calls, gaming traffic, push notifications, or apps that deliberately bypass system proxy settings. If you need full traffic coverage, a VPN is a better tool. A VPN tunnels everything at the network interface level, regardless of what protocol the app is using or whether it respects proxy settings. So the rule of thumb is Wi-Fi proxy is good for web traffic and lightweight cases. VPN is better when you need everything routed. A Wi-Fi authentication is another area worth talking about. There are two main models. The first is user and password authentication, where you enter credentials each time. The second is IP whitelisting, where the proxy provider checks your incoming IP against an allowed list and only accepts connections from approved sources. IP whitelisting is convenient because you do not have to manage credentials on every device, but it requires a static IP, which most home users do not have. Username and password is more flexible, but easier to leak if your config files end up somewhere they should not be. Use whichever fits your situation, and rotate credentials periodically if you are doing anything sensitive. All ones, blue fit false. The first one is using free public proxies. Free proxies are almost always slow, unreliable, and frequently malicious. Many of them log your traffic, inject ads, or worse, capture credentials. Never enter banking or login credentials through a free proxy. The second pitfall is forgetting that the proxy is set. People configure a proxy for testing, then weeks later wonder why their internet is slow or why certain sites are not loading. Always remember which device has a proxy active, and clear the settings when you are done. The third pitfall is mismatched protocols. If your provider gives you a SOCKS 5 proxy, you cannot enter it as an HTTP proxy in your settings, because the protocols are not interchangeable. The fourth pitfall is enterprise networks that already have a transparent proxy at the gateway. If you try to layer a personal proxy on top of a transparent corporate proxy, you can end up with broken connectivity, double routing, or triggering security alerts on the network team's monitoring tools. The fifth pitfall is DNS leaks. When you set an HTTP proxy, your DNS queries do not necessarily route through the proxy. Your device may still resolve domain names through your local DNS server, which leaks information about which sites you are visiting. If DNS privacy is important to you, use a SOCKS 5 proxy that supports remote DNS, or layer a DNS over HTTPS configuration on top. There is also a common misconception that adding a proxy automatically makes you anonymous. It does not. The proxy provider can see everything you do, especially with HTTP traffic. And even with HTTPS, they can see which domains you are visiting based on the SNI in the TLS handshake. If you choose a sketchy provider, you have just handed them a front row seat to your browsing. Choose providers you actually trust. And remember that the goal of a proxy is usually to change your apparent IP, not to provide total privacy. A traveling professional uses a Wi-Fi proxy on hotel networks to route through a paid residential proxy in their home country, so banking sites do not flag the login as a foreign access attempt. A QA engineer at an e-commerce company uses a proxy on her laptop to test how the site loads from different geolocations without setting up VPN gateways. A small business owner running multiple Instagram accounts uses a mobile proxy with a sticky session per account, so each account always appears to be on its own consistent residential mobile IP, which reduces the risk of mass bans. A web scraper running a small data collection job sets a proxy in Charles or Fiddler to inspect what API calls a website is actually making, so he can replicate them with the right headers in his own script. Let me go deeper into some technical details that often confuse people. The first is the difference between an HTTP proxy and an HTTP proxy. See? The naming is misleading. An HTTP proxy is a proxy that speaks the HTTP protocol for its instructions to the proxy server. It can still tunnel HTTP's traffic using a connect method. So when you see a proxy described as HTTP8, that does not mean it cannot carry encrypted traffic. It means the negotiation between your device and the proxy uses HTTP semantics. An HTTPS proxy in the strict sense is a proxy where the connection between you and the proxy is encrypted with TLS, and the proxy then handles the request. Most consumer proxy products are HTTP proxies that tunnel HTTPS via Connect, which is perfectly fine for normal web browsing. SOCKS 5 proxies use a different negotiation entirely, and are protocol agnostic. The These are JavaScript files that your device downloads and runs to decide which proxy to use for which destination. Hack files allow complex routing rules, like sending corporate traffic through one proxy and external traffic through another, or bypassing the proxy for internal addresses. They are common in enterprise environments and almost unheard of in consumer setups. If your IT department gives you a PAC URL, that is what you enter in the automatic configuration section of your settings. Behind the scenes, your device runs the JavaScript on every connection and follows the rules. The third detail is captive portals and proxy conflicts. When you connect to a coffee shop or hotel Wi-Fi for the first time, you usually get redirected to a login page. This is a captive portal. If you have a proxy already configured, the redirect may not work because your traffic is being sent to a proxy server that is unreachable from inside the captive portal network. The fix is to disable your proxy temporarily. Complete the captive portal login, then re-enable. Some modern operating systems handle this automatically by detecting the captive portal before applying the proxy. On Android and iOS, Wi-Fi proxy settings apply only when you are on that specific Wi-Fi network. On cellular data, the proxy does not apply unless you use a pair-app proxy configuration or a VPN. Some apps like Telegram have built-in pair-app proxy support that works regardless of which network you are on. Other apps only respect system proxy settings. If you need proxy coverage across both Wi-Fi and cellular, a VPN profile is usually the cleanest solution. The fifth detail is iOS configuration profiles. Enterprises can deploy iOS profiles that include proxy settings, and these profiles apply globally rather than per Wi-Fi. If you ever install the profile from work, your proxy settings may be inherited from that profile and not editable directly in Wi-Fi settings. There are also use cases I want to expand on. Mobile proxies enter the picture when your workflow is sensitive to IP reputation. If you are managing multiple accounts on platforms like Instagram, Twitter, TikTok, Reddit, or eBay, the system proxy on Wi-Fi is not the right tool for the job. You want per account, per browser profile proxies with sticky sessions. The reason is account separation. Setting a Wi-Fi proxy means every app on your device, including notification services, push registrations, and background sync, routes to the same IP. That IP becomes associated with everything you do on the device. For account work, you want isolation. The pattern is to use an anti-detect browser, assign one mobile proxy per profile, and not use the Wi-Fi proxy at all. The Wi-Fi proxy is great for general browsing and access. It is the wrong tool for account separation. Those sticky sessions deserve a dedicated explanation. A sticky session is a setting on your proxy provider that keeps you on the same IP for a configurable window of time. Without sticky, the proxy may rotate IPs on every request, which breaks any workflow that depends on session continuity, including logins, shopping carts, and multi-step forms. With sticky enabled, you stay on the same IP for the duration of the window, then either keep it longer or rotate to a new one. Mobile proxies in particular benefit from sticky sessions because the natural IP rotation of cellular networks can otherwise interrupt your workflow at random. Configure your sticky duration to cover your typical session length plus a buffer. Let me also cover one more pitfall that bites enterprise users. If your laptop has a corporate proxy applied through group policy on Windows or a mobile device management profile on Mac, you may not be able to override it from the local settings UI. The setting fields are visible but grayed out, or your changes get reverted on the next policy refresh. The right approach in this case is to talk to your IT team. Trying to circumvent corporate proxy enforcement is a great way to end up in a security incident. The pitfall I see most often with consumers is mixing up the proxy host with the proxy port. People paste the entire string into the host field and nothing works. Read your provider's documentation carefully and split the string at the colons into the correct fields. A subtle pitfall is forgetting that some apps deliberately bypass system proxy settings to avoid corporate inspection. WhatsApp, Signal, and various banking apps sometimes hardcode their network configuration to ignore the system proxy. If you set a Wi-Fi proxy and one of those apps is not working through it, that is by design. You either need to live with the inconsistency, use a VPN instead, or accept that those apps will not be proxied. Another subtle pitfall is the security risk of MITM style inspecting proxies. Some enterprise proxies decrypt your HTTPS traffic by installing a corporate certificate authority on your device. This means the company can see everything you do. If you are on a corporate device, assume your traffic is visible. Do personal business on personal devices. Let me give you a few more real-world examples to bring it together. A consultant who travels constantly keeps a list of trusted proxy providers in different countries. When he lands in a new city, he sometimes sets a Wi-Fi proxy on his laptop to route through his home country, so banking and account access does not flag geo-anomalies. A privacy-conscious freelancer uses a Wi-Fi proxy at home to route through a known good IP for his email and CRM tools while leaving the rest of his apps direct. A small e-commerce team uses Wi-Fi proxies during QA to test their site from different geos, validating that pricing, shipping options, and product availability render correctly per region. A solo developer building a multi-region SaaS uses a Wi-Fi proxy to verify that his application's geolocation logic is correct, switching between US, EU, and Asian proxies on a test laptop. All of these are perfectly mainstream uses and none of them require advanced infrastructure. For users who want to go deeper, there are advanced setups that build on the Wi-Fi proxy concept. You can run a local proxy server on your laptop like Squid or Prevoxy and have all your devices route through it. The local proxy can then chain to an upstream provider, log everything for debugging, or apply filtering rules. You can also use a Pi-hole or AdGuard Home for DNS-based filtering alongside a system proxy for IP-based routing. These setups are project tier and well outside the typical use case, but they exist if you want them. The point of mentioning them is that the Wi-Fi proxy is one piece of a larger toolkit, and as your needs grow, you can layer additional tools on top. Alright, that is everything for today on what is a Wi-Fi proxy. We covered what they are, how they differ from VPNs, how to configure them on every major platform, the common pitfalls, and the use cases where they actually shine. If you want deeper guides on residential proxies, mobile proxies, and sticky session setups for serious workloads, head over to dataresearchtools.com where we have full provider comparisons and setup walkthroughs. Until next time, take care and stay private out there.